So slow. All right. So, ladies and gents, so if I asked you to graph that, somebody said, oh, we did this in the last chapter. You are right, we did do this in the last chapter. And I wish that students would understand about math, how cumulative it is. It's not like other subjects where, oh, I didn't get that, but it's okay. Next chapter, we're going on to something else. It won't matter anyway. Math is not like that. Unfortunately, math, if you don't get what we're doing in this chapter, you're probably not going to get what we're doing in the next chapter either. So if I asked you to, you all should be able to graph that, right? Remember? Well, watch now if you can't graph it. The way we did it, we let x equals 0, and we took the equation and we plugged in x equals 0 right there. So 0 plus y equals 1. What's y? 1. Y equals 1. So when x is 0, y is 1. That's one ordered pair. Leave that bottle alone, please. I don't like to talk over a ruckus. So there's 1 point on my line. Now what do? Let y equal 0. Now I let y equal 0, and I take the same equation again, but now I plug in 0 for the y value, right? So x plus 0 equals 1. What does x equal? 1. So there's another. Be careful, the ordered pair. Here's the x. X is 1. Y is 0. There's the other point on my line. And then you're just going to plot those and connect them, right? 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 Aww. So I have 0, 1. 0 right or left and 1 up. And I have 1, 0, 1 over and 0 up. And then I'm going to carefully try to connect on my less than even homemade graph up here. And when you graph these, arrows at the ends. Why do we put arrows at the ends? Because it keeps going. And also, what I would like you to do is go all the way from one side of the graph all the way to the other. Don't just make a little arrow right here. Go all the way across your whole graph. So you could do this if I asked you to, hopefully. It was on the test. Now, over here. Oh, and by the way, this line, it's made up of a whole bunch of points, right? It's made up of a whole bunch of x, y, x, y, x, y, x, y. This is a whole bunch of points on the line, an infinite number of points on the line. And every one of those points solves this equation. What about this one? If I asked you to graph this one, 2x minus y equals 8. Could you graph that one? Could you? Same way, right? Let x equal 0. So if I let x equal 0, I'm going to plug in right here. 2 times 0. Now be careful. This is 0. This is negative y. Negative y equals 8. Cannon, what do you have to do to that? Divide by negative 1, maybe? So that the negative goes away, and you get y is negative 8. So there's an ordered pair, right? 0, negative 8. There's one ordered pair. Now what?
Let y.
Now you do the other. Let y equal 0. And you take your same equation, but now we're going to let y equal 0. 2x minus 0 equals 8. So do I really need that? Minus 0? It's just 2x equals 8. What is x? So x is 4 when y is 0. What's my ordered pair? X is 4, y is 0. Now you have two ordered pairs, right? Can we plot those and connect them? Plot those and connect. Plot those and connect. So I have 0 right or left, and 1, 2, 3, 4, 5, 6, 7, 8 down. And then I have 4, 0. I have 4 over and 0 up or down. Oh boy, connect with my warped. Oh boy. I already screwed it way up. Well, you know what you do then? You make a really thick point. Sorry. Your graph paper will be nice, way better than mine up here. That's homemade. Arrows, and don't forget, it's got to go all the way from one side of your graph to the other, from top to bottom, from side to side, right, Cannon? And remember again, this purple line represents a whole bunch of XY, XY, XY pairs. And every one of those XY pairs on this line will work in that equation. And by the way now, everybody should know how to do all of this so far, right? 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 Well, here's today's lesson. Here's today's lesson. We're going to solve in this chapter systems of equations. A system of equations just means you have two equations at once. And notice, the two equations I picked, they're the two we just graphed, right? When you solve a system of equations, you're solving two equations at once. So what we are looking for, remember when we had xy's that solved, does this one solve, does this one solve? We're looking for an xy solution. X equals, y equals. 1x, 1y, that will work in both of these. I'm looking for 1x and 1y that'll work in both. Well, Before you say anything, come back over here. All the points on the blue line are XY pairs that work in this equation. All the points on the purple line are XY points that work in this equation. And I am looking for now 1x and 1y that will work in both. Where could I find an x and a y that would work in both? Say that again? She says, where they intersect. What do you say? Where they intersect. Very good. So wherever they cross, that's your solution. So you have to look, where do they cross? X equals 1, 2, 3, and y is 2 down. So your one solution is just x equals 3, y equals -2. That's the only new part. All you have to do is look to see where they cross, and that's your answer. So most of today's lesson you already know. All you do is graph two equations on one graph and look to see where they cross. Wherever they cross, that's your solution. Those coordinates are your solution. Does that make sense? Does that make sense? Do you have any questions so far? There's one other thing that might happen. So you know how to graph, so I'm not going to do the whole thing, but the other thing that might happen is this. So you graph your first line, and there it is. That was a pretty straight line. And then you graph your second line, and there it is. What are those two lines called? Parallel. Where do parallel lines cross? Never. They never do. Well, remember, the whole idea with this method is to find the x and the y where they cross. Well, if they end up being parallel, they're never going to cross. So what's your solution going to be then? No solution. So if you end up with parallel, you're going to get no solution. And I believe there's two of those in today's. Let's just see.
You have to graph it and then figure it out.
Right, you have to graph it and then figure it out. One other thing I want to tell you, actually there's two other things. This point where they cross, all the problems I picked, they will cross at whole numbers. Now, your x and your y, you might get 2.5 and 0 for your x and y. Just to estimate, go 2.5. Our graphs are going to be really small, so you might get a fraction for your x or your y. But the point where they cross should be whole numbers. Does that make sense? And the other thing, I picked the very first problem is this. The very first problem is x equals y. So if you put in x is 0, what's y? 0. If you put in y is 0, what's x? 0. Oh, geez. Can you give me some more coordinates where x and y are equal? If x is 1, what's y? 1. If x is 2, what's y? 2. If x is 3, what's y? And so on. So there's a whole bunch of points you can plot for the x equals y. I think that might be all I have to say. Do you have questions? Oh, and can you see why you needed to learn the last chapter before this one? Can you see? Because if you didn't learn how to graph a line, now we're going to be in trouble. Yes? Do you have questions? Anybody? I have graph paper for you, and it'll be a little bit better than my homemade stuff up here. I'm on page 415. And I would like you to do WE 1 and 3 through 8. 1 and 3 through 8. And did I say, I think I said already, there are 2 that are no solution. There are 2 no solution.